Okay, searching for the information. I've gone through a lot of slides. It's all in that field guide to human-centered design. It's all in our textbook, chapter 2 of the textbook, about the techniques you use to get information from the customers, or get information, period, stakeholders and so forth, not just the customers, but competitive analysis. So here's another list. You don't have to do all of these, but do some of these and report it in your notebook. I want to see that you've done a thorough job of research. That's what I want to see in your notebooks and in your progress report. Okay. Criteria constraints, cost, scope, and time, the big three. I had a project at one firm, and the boss said, well, I made my plan, my timeline, and it was taking about twice as long as what the boss wanted. He said the time needs to be cut in half. I said, okay, we can switch activities around. Will it get the whole thing done faster? I said, no, that won't help. I said, okay. Then I looked at scope. Well, we can eliminate these steps. We don't have to do this. He said, no, we got to do it. Okay. Then I looked at, okay, we can hire some people, we can get some contracts to get some of this work done. Oh, no, we don't have the budget. And I looked at him and I said, you're not giving me anything to work with. This problem is over-constrained. You know? Okay, design limitations. Are there legal type things going on? What's the best solution? Performance indicators, design variables. So horsepower, performance indicator. Measures of goodness. Miles per gallon is a measure of goodness or a figure of merit. They're called two different things. Figure of merit, FOM, or measure of goodness, MOG. Miles per gallon is one such measure. It illustrates what we mean by measures of goodness. Because if you report that a certain vehicle goes X number of miles on a tank of gas, well, how do you know which vehicle you're going to spend the least amount of money in gas on? Because tank sizes can change. They can be different. But by using miles per gallon, then people can say, oh, yeah, this is a more efficient car than another car. Defining requirements. So here's a Dilbert cartoon. I need to know your requirements before I design the software. First of all, what are you trying to accomplish? I'm trying to make you design my software. Okay. It goes on. What are you trying to accomplish with the software? It goes through. The guy never says, can you design it to tell me my requirements? Well, no, you can't. This guy over here needs to tell her what the requirements are. And we understand the requirements after we go through all of the searching phase and the customer interviews and things like that. Two basic types of requirements. One is functional. So this little illustration illustrates functional. A car takes a person from point A to point B. Square wheels won't work. This is a design requirement. So when you lay out a bathroom, these are the requirements. These are the constraints, the building codes to do that. This is broad. This is narrow. Design requirements are narrow. Functional requirements are broad. You start with the functional, then you get down to your ideas of what you want, and you start zeroing in on the design requirements. Sometimes we over-design things. Functional requirements, abstractions, broad as possible. What's the original problem? Find the root cause of the problem. Verb-object combination. You want to maximize the design space, options, flexibility to use innovative solutions to solve it. What's the core function? Does not imply a solution, by the way. So here's functional requirements of a door. It doesn't say it has to have a latch or a lock or hinges or anything like that. I mean, provides access, limits access. You know, a zippered piece of cloth would work like you see on a tent. We don't have doors on tents, but we still have zippered things that we open the flap and go in and close the flap. So it does its job. SolidWorks, it's a CAD program. Design and document 3D objects. A car provides transportation, saves energy. Broad. Design requirements, we narrow. Our design space is smaller. You don't have as much design freedom. You're starting to specify exactly size and shape and limits, constraints, like the bathroom layout a few slides back. It tells, well, it's got to be a minimum of this and a maximum of this. So much distance. Criteria. How are we going to know if it's a good design or not? Quantitative and measurable. So at the end, we can say, well, it does this, etc. Describe the problem, not the solution. Again, stay away from the solution at this stage. You're trying to understand the problem well, like Steve Jobs and Einstein said. Get a real focus on the design of the problem. So, summary. Design, specifications to make an artifact. This problem definition stage is very important. If you design the problem, if you miss it, you could be making useless crap that nobody will use because you missed the real problem. The brick form in Africa that wasn't used. But what the customer really needed was a way to transport the bricks. The fan, and also by thinking through this, the engineers might have figured out a fan to blow the boxes off the conveyor belt earlier. I remember in the semiconductor industry, I made a pinwheel. Said, okay, how are we going to measure the flow rate of air through the laminar flow hoods? And you put a pinwheel on a paper clip. And the pinwheel, when you have a certain flow rate, it rotates at a certain speed. So you know the flow is laminar. If it rotates too fast, you know it's turbulent flow. So understanding the problem at its very basics. Okay. Gathering information, studying the library from the customers, field guide to human-centered design. Use those tools that are in there. Solutions to similar problems. And then develop your requirements. Okay, that's it. I'm going to go to the next chapter after this.